today, this is my fourth topic on my calculus subject, which is the continuation ulit for the defining our limits. And this is part of the limits, the rule of limits to how to uh, solve or to find the value of the limits. So this report is all about on the L'Hopital's rule. So this L'Hopital's rule is the application of derivatives if we evaluate the limits of a function, particularly a rational function. If we evaluate the function in the value of x, the result is indeterminate form, like 0 over 0 or plus minus infinity or plus minus infinity, or we can call this one the indeterminate form, like we discussed ahead of my review videos. And we can apply the L'Hopital's rule to find and evaluate the limit of the function. So let's start. So L'Hopital's rule is applied by taking the derivative of the numerator and derivative of the denominator separately, not the derivative of the quotient. If f and g be functions that are differentiable on the open interval, I accept the possibility to the numerator number of a in I suppose that for all x is not equal to a in I, g of x is not equal to 0, then if limits of f prime quantity of x equals to 0 and limits of g prime the quantity of x as x approaches to a is equal to 0, if limits of f of x over the g of x as x approaches to a is equals to L, it follows that limits of f of x over g of x as x approaches to a is equals to L. So the theorem of valid, or the theory of this limit, is all about the valid of all limits can be right-hand limits or all the limits can be left-hand limits. Okay, so let's start. The limits cannot be indeterminate form, which not be applicable to the result if our limits can be have the result of the 0 over 0, or we can call this one the indeterminate form. So if we want to find the limits by using the L'Hopital's rules, also can be applicable if limits of f of x as x approaches to a is equals to the plus minus or positive negative infinity, and if limits of g of x as x approaches to a equals to positive or plus minus infinity, and limits of f of x as x approaches to positive minus infinity is equal to 0, positive minus infinity, and limits of g of x as x approaches to positive minus infinity is equal to 0, positive minus infinity. So kung meron daw tayong limits of g of x or g over the g of f of x over the g of x as x approaches to a that is na ma-equal to sa 0, dili siya applicable. So we need to apply the L'Hopital rules. By that, we need to set the derivative and then evaluate again to find the limits of the function. Sige, for example, so we have the limits of x squared minus x plus 12 over the x squared minus 3x over minus 4 is as x approaches to 4 is equals to 4 squared minus 4 plus 12 is equals to over 2 squared minus 3, which is our x is 4 minus 2 over 4. So 4 squared plus minus 4 minus 12 is equals to 0, and 4 squared minus 3 times 4 minus 4 is equals to 0. So it means this is a determinate form. So we need to do is to make that in the indeterminate form. So, ang gagawin natin, we need to apply the hospital's rules. So, which is, we need to derive or to get the derivative form. So, let's have 2x minus 1, which is our denominator, the value of our denominator, the derivative form of the denominator, and the numerator rather, and then the derivative form of the denominator is the 2x minus 3. So, evaluate again the limits. So, we have limits of 2x minus 1 over the 2x minus 3 as x approaches to 4. So, now we get the value of our limits. So, limits of 2x minus 1 over 2x minus 3 as x approaches to 4 is equals to 2, which is our x is 4, and minus to 1, and 2 times 4 naman, minus to 3. So, 2 times 4 is equals to 1. We could come up of 8 minus 1. So, 2 times 4 is 8. 2 times 4 is 8. So, 8 plus, minus 1 is 7. And 8 minus 3 is 5. So, we can come up with this answer. So, this is the value of our limit. So, this is the limit's value. 7 over 5. Another example to use the L's hospital rules. So, let's find the limits x over 1 minus e raised to 0 as x approaches to 0. So, equals to x is 0, and over the 1 minus e raised to 0 equals to 0, copy the 0, over 1 minus our a is have the value of our a raised to 0 is have the value of 1. So, 0 over the 1 plus minus 1 is 0. So, this is the determinate form. So, now, to get the value of our limits, or to get the true value of our limits, we need to derive it. So, we need to use the L's loss of hospital rules. So, first, derive it. The derivative of this these functions are 1 over which our numerator is 1 and our denominator is negative e of raised to x. So that is the derivative. So now evaluate the limit again with this value, limits of 1 over negative a raised to x as x approaches to 0. So we can come up with this answer. So limits of 1 over negative x raised to x as x approaches to 0 is equals to 1 over negative e raised to 0, which is our x, and equals to 1. Our negative a raised to 0 is equals to negative 1. So, 1 over negative 1 is we can come up with the answer of negative 1. So, that is the value of our limits. So, that can be used or can be derived or can be do the LS hospital rules. So that's it. All my report. I hope you have understanding kahit konti lang. So see you on my next report. Thank you.